Algebra 1, Section 9.7, Factoring Special Cases. Quick note, you should only be watching this video and attempting this homework assignment after you have done all of the rest of them in Chapter 9. So we went 9, 1, 2, 3, 4, 5, 8, 6, 7. And this is kind of a wrap it up lesson. Pretty easy if you understood everything up to this point. This will not be a challenge for you. The special cases are the perfect square trinomials and difference of squares. We've already dealt with these as it pertains to FOIL, okay, and multiplying and distributing. So this is just going to be the reverse of that, as is the point that I keep making, that factoring is the reverse of distributing, okay? Now, some teachers will teach this in a way that they want you to recognize just by looking at this that this is a special case. I do not think you need to do that. I think you really just need to go about this in the same way that I've already taught you. That's why I don't think this is a challenging lesson, because if you've understood 9.6, you're going to understand this concept right here. So they give me m squared minus 6m plus 9. Now, before we actually do this problem, I do want to make one point about factoring by grouping. I did ask you in 9.6, by the end of 9.6, to decide, at least for yourself for the year, which way you're going to be as a factorer. Do you factor by trial and error, or do you factor by grouping? This has a number that is in front of m that is understood to be 1. I do not see the benefit in using factoring by grouping when the number is 1. This is why I didn't teach you factoring by grouping in a previous section, section 9.5, when the lead coefficient was 1. Okay, when that number is 1, it doesn't make any sense. Let me show you why. AC, 1 times 9 is 9. What are the factors of 9? 1 times 9, 3 times 3. Okay? So then what do we do? Well, we're going to rewrite the middle term. You're not doing this. I'm just showing you why you shouldn't do this. We're just going to rewrite the middle term as minus 3m minus 3m. So you have m squared minus 3m plus 9. And then you're going to factor by grouping by taking out an m, which would leave you with m minus 3. And then here you're going to factor again on the latter half by taking out a negative 3, which would leave you with m minus 3. And then you have m minus 3's minus 3, m minus 3's, just as we did. You see, it does work. This is correctly factored. But the process that you went through there to use factoring by grouping is not really necessary, because you had to come up with the 3 and 3 versus the 1 and 9, which is exactly what you'll have to do if you would just use trial and error. Okay, so for everybody now, I think on this type of problem, when the lead coefficient is 1, you should just use trial and error. Okay, and if you use my advice, the advice that I gave in the latter half of 9.8 and then again in 9.6, pick numbers that are closer together. Actually, I don't think I said it in 9.8 because we were doing grouping, but when you're doing trial and error, pick numbers that are closer together. For 9, that's 3 and 3. You can't get any closer together than the same thing, right? 3 is the same as 3. And start with that. Now look, if you're just approaching this like you would have in 9.6, maybe it's 3 and 3, maybe it's not. If it's not, you go with 1 and 9, okay? But if it is 3 and 3, and these would both be minus, because negative 3 times negative 3 gives you positive 9, and negative 3 and negative 3 will give you negative 6m as a middle term. It turns out to be a perfect square trinomial. M squared minus 6m plus 9 turned out to be a perfect square trinomial. And this is the factored form of it, okay? Now, yes, you can. Somebody is probably wondering, can you write that differently? Yes, you absolutely can write this way. Both of these are acceptable answers. But again, I don't think in this case you should attempt and take the amount of space on paper to do factoring by grouping. It's just not necessary here. Use trial and error. And just to be clear, I don't mean just use trial and error for the perfect square trinomial, because you may not even be able to recognize that it's a perfect square trinomial. I mean use trial and error when the number in front of m is 1, when the lead coefficient is 1. All right, next example. Here, let's go ahead and let's use grouping. They're telling us that the area of this square is 16h squared plus 40h plus 25, and they want us to find the length of a side. Obviously, the length and the height are the same thing on a square, which they tell us that this is. So essentially they want us to factor 16h squared plus 40h plus 25, and the two links that we come up with, the two binomials, had better be the same thing. So let's go ahead and do that. I mean, 16 and 25, if you just did trial and error, you might look at 16 and 25 and go, this is going to take a while, right? There's a lot of different things to try. If you do trial and error and you follow my advice, though, 16, the numbers that multiply to give you 16 that are closest together would be 4 and 4. The numbers that multiply for 25 that are closest together would be 5 and 5, and you're going to find out that that works, right? So it works really well, and you turn out to be to seem really smart when you are a trial and error person, and the thing ends up being a perfect square trinomial. But both methods work, and I will not discount either one. Let's do grouping. 16 times 25 is 400. Okay. Now, if I were to list all the factors of 400 that multiply, pairs of multipliers that give you 400, this would take a while. And I'd start with 1 and 400, 2 and 200, 4 and 100, 5 and 80, 8 and 50, et cetera, et cetera. It's going to end up being down a ways. It's going to end up being 20 and 20. 20 times 20 would be what you want to use, because those will add up to 40h, meaning that we're going to write this as 16h squared plus 20h plus 20h plus 25. Okay, now again, if you've already determined that you factor by trial and error, then this isn't your method. You're going to come up with the same end result, but you're not having to go through these steps. You've decided that trial and error is your method, and you're willing to deal with being wrong 1, 2, 3, 4, 5, however many times it takes before you come up with the right combination. But just for contrast, we're doing this one by grouping. I can take a 4h out of this, which would leave me with 4h plus 5. Over here, I can take out a 5, which would leave me with 4h plus 5. And that means that you have 4h plus 5, which really accounts for this, of the same thing in two parentheses, 4h plus 5s. And that is a correct answer. Or again, of course, you may write this as 4h plus 5 in parentheses squared. Okay, let's deal real quickly with difference of squares. You'll recall that when in an earlier section when I gave you something like x plus 3, x minus 3, and when you multiplied them, you got x squared minus 3x plus 3x. The middle two terms would cancel out, and you'd be left with just minus 9. Well, that's exactly what's going on here. You should recognize this as a difference of squares. In fact, a more complete set of advice would be this. If it's exactly two terms, look for a GCF, which we should always be doing now. And I did say in the last lesson that I was going to start to say that more often, and I'm saying it now. Look for a GCF. It could be that it's GCF factoring. It could be that it's a difference of squares. It could also be both. I think we're going to see that happen on the next example. It could be both. But in this case, there's not something that I can divide out of both, but this is a difference of squares. And it's just a pattern that you should learn. If it's two terms and it's a difference, meaning minus sign, here's a perfect square, here's a perfect square, meaning that a squared's square root is something that's convenient and meaningful and not some weird irrational number. The square root of a squared is just a. The square root of 16 is just 4. You can put a 4 here and here. One of them is plus and one of them is minus. A plus 4 times a minus 4. That's factored form. There isn't an alternate form for that. It's a plus 4 times a minus 4. Real quick. What if they gave you a squared plus 16? What if they said factor a squared plus 16? It's not a difference of squares. It's not going to be the same answer as we got above. Somebody might say, well, I think it's going to be a plus 4 times a plus 4. That is not correct either. If you multiply out a plus 4 times a plus 4, you're going to get a squared plus 8a plus 16. Okay, you're going to get a middle term. In truth, this is not factorable. Okay, so just watch out for that. That might occur at some point, especially in chapter 10, that might even come about. this is not factorable. In fact, this is as factored as it gets. Okay? It's not a difference of squares. It's not anything that we've discussed. It's just not factorable. All right, real quick. Here's a similar problem to the last one, except you can divide out something from 9b squared and negative 225. Now think about what that might be. I'll give you a minute. Did you say 3? If you said 3, that's correct. I mean, it is divisible by 3, but that's going to cause a problem because then you're not going to have a perfect square trinomial. In fact, the largest number that comes out of both of these is 9. Now take a look at their work here. This is incorrect. While they did factor correctly, so to speak, I'm doing air quotes with my fingers right now. While they did factor correctly in a way, you can factor a 3 out of this, and you can factor a 3 out of this. And if I did that, if I took a 3 out of that first one, you'd have b plus 5. And if I took a 3 out of that second one, you'd have b minus 5. And then you can multiply the two 3's, and you'd have 9 times b plus 5 times b minus 5. This is completely factored. This is not. Okay? Now, the way they did it is inefficient. Okay? Even if you follow what they did to this point and then you follow my work forward, that's not an efficient way to do it. What we ought to do instead is just factor out the GCF from the beginning. We ought to factor out a 9. And that would leave us with b squared minus 25, which is easy to factor because it's a difference of squares. b plus 5, b minus 5. This is completely factored. And if you gave me something that was 3b plus 15 and 3b minus 15, that's going to be not correct. Okay. And one more. Similar to the last one, you can take out a 5 though. 5. You look at that and you think, well, that's not a difference of squares, right? 5x squared is not a perfect square. 80 is not a perfect square. But if you would divide out a 5, it will be. 80 divided by 5 is 16. And then you can quickly factor that into x plus 4 times x minus 4. Okay, that's all. That concludes your chapter. And thank you for watching.